An introduction to derivatives. So what exactly is a derivative? Well, the definition of a derivative is to find the slope of the tangent line, and a tangent line is a line which touches a point at a specific curve once. To do that we have to find the slope of the secant line first. Now how do we express a derivative? A derivative can be written in two different ways. The first way is if we write it as a function of x, but after the f there should be a little apostrophe. That apostrophe has a name which is called prime. If we put it all together it would become f of x prime. That's the first way. The second way is where you can write it as d over dx of f of x, which also represents a derivative. With that out of the way, let's just dive straight into an example. Here we have the graph f of x equals to x squared, and we want to find out the derivative of this function, or in other words we can find what f prime of x is. Or in other words, d over dx of the function x squared. To make this a little interesting, let's suppose we want to find out the derivative at the point x is equal to 2. Now, how do we solve this? Well, let's choose two random points of a graph which we'll call a and b, and between those 2 points you will see this line which is considered as a secant line. To find out the derivative we have to find out the slope of that specific tangent line. Finding the derivative of a tangent line is generally the same thing as finding the slope of a secant line. A secant line is a line which touches 2 points at a curve once. Well, look here, we are given 2 points, a and b, therefore, to find out the derivative we have to find the slope of the distance between these 2 points. Well, how would we do that? Well, we created a tangent line on the point 2, and we know that a is at the left of 2 and b is at the right of 2. To pick numbers which are close to the actual number you created the tangent line at. You also don't want to work with decimals since that will just make things confusing. The two numbers that we have to choose are obviously 1 and 3. Now we can find out the derivative by finding the slope. By the way, a is equal to 1 and b is equal to 3. Now the formula for a slope is f of b minus f of all over b minus a. Well, we know what b and a is, so we can rewrite that as f of b minus f of over 3 minus 1, which simplifies to a half of f of b minus f of a. Well, f is just the function. So, if we put b and a into the function which we know is equal to x squared, we'll get 1/2 of 9 minus 1. We got 9 but squaring 3 and 1 by squaring 1. This now simplifies to 8 divided by 2, which is 4. This is our answer. What I did here is what the definition of a derivative is. However, there is also a short way of solving this. So remember that we said that we can represent this problem as d over dx of x squared. Now there's something known as the power rule, and the power rule basically says that whatever the exponent is, bring that exponent down and then subtract 1. We can represent that as a function of x to the n power. To find the derivative of this, you carry down the n and subtract 1, which will get you nx to the n minus 1 power. Now if we just let n equal to 2, we will get back to our question. So the answer is 2x to the 2 minus 1 power, which is equal to 2x, but wait. We're not done yet, because remember this is just what the derivative of x squared is. We also have to plug in our 2, which is the point where we set the tangent line. So x is equal to 2. We have to plug that into 2x, which will then finally get our answer to 4, which we obtained by doing the long way.